Hi students, yesterday we discussed about the electric potential and potential difference. Now today we will discuss about the electric current flow. We know that if the potential difference is there in between two particular points, suppose here we take 2 points A and B for any conductor. A and B are the 2 points of a conductor, and suppose the electric potential at A is VA and the electric potential at B is VB. And if these two potentials are different, so in between these 2 points, the potential difference is VA, difference VB, this is a difference symbol. That means you can say VA minus VB if VA is more, and you can say also VB minus VA if VB is more. So here we want to say in between these 2 points of a conductor there is a potential difference. Remember one thing, if you take 2 containers filled by water, and if there is a difference of water level, suppose this is one container and this is another container, here the water level is up to this and here the water level is here, this one. And if you connect these 2 containers through a pipe, then the water starts to flow from one container to another container. 2 containers, here the water level is more, here the water level is less. Now if you connect these 2 containers through a pipe such a way, then water starts to flow from the high water level to the low water level. So here we can say that the water is flowing due to the difference of water level between these 2 containers. Similarly, if in between these 2 points the potential difference is there, then the charge particle also starts to flow from one point to another point depending upon the potential difference and the types of charge also. So as the water is flowing due to the water level difference, so if you maintain one potential difference between these 2 points, then the charge particle starts to flow from high potential to the low potential. Now question is, if Q amount of charge is flowing, charge flow is equal to, suppose Q charge is flowing during time T, during time T. So what is the current flow? Here the Q charge is flowing because of the potential difference, and during the time T, then the current flow or electric current if you define it by the I is equal to Q by T. I is equal to Q by T. So this is the current flow, electric current. That means charge flow per unit time. This is known as the electric current, that is denoted by the letter I. I is equal to Q by T. So I repeat once more. What is the electric current? The charge flow per unit time. This is known as the electric current. Now question. What is the unit of this electric current? What is the unit of the electric current? The unit of electric current is what? Ampere. Unit of electric current is ampere. Now we will define the term ampere. So is it clear? The charge flow Q during time T, electric current I is equal to Q by T. Now we define the unit of current flow. Listen here, that here I is equal to Q by T we know, just to discuss here. Suppose Q is equal to 1 coulomb and T is equal to 1 second. Q is equal to 1 coulomb, T is equal to 1 second. If, now put this value in this equation, then you get I is equal to Q by T is equal to, Q means 1 coulomb, T means 1 second. So I is equal to 1 coulomb by 1 second. This is known as 1 ampere. So this ampere is the unit of current flow. This ampere is the unit of current flow. So how can we define the ampere? If 1 coulomb current is flowing, if 1 coulomb current is flowing during time 1 second, then the current flow is known as 1 ampere. I repeat once more, 1 coulomb current will flow during time 1 second, then the current flow is known as 1 ampere. Okay? Now, we will go for the next topics. Now the direction of current flow. We know that due to the flow of charge, the current is flowing. Now what is the direction of current flow? Listen one thing, charge flow means that charge may be positive, may be negative. So if the negative charge is flowing, then what will be the direction of current flow? And similarly, if the positive charge is flowing, then what will be the direction of current flow? Remember these things. If the negative charge is flowing, then the current flow, the direction of current flow will be opposite to the direction of flow of negative charge. Suppose negative charge particles are flowing east to west. Negative charge particles are flowing from east to west. That means current is flowing from west to east, opposite to the direction of flow of negative charge. And if the positive charge is flowing from east to west, then the current flow also from east to west. That means direction of current flow is same as the direction of flow of positive charge. So such a way we can define the direction of current flow depending upon the types of charge flowing. Now one thing, current cannot flow through every material. If you take a piece of plastic, the current cannot pass through a plastic. But if you take a piece of a copper wire, then the current can pass through the copper. So we can say that few materials through which the current can pass very easily, like the copper, gold, silver, aluminium, these metals, these are known as the conductor. These are known as the conductor. Through it current can conduct, current can pass. But through the wood current cannot flow. Through the plastic current cannot flow. So these types of material through which current cannot flow, these types of materials are known as insulator. Now we can say just only one few basic things. Current can flow through the metallic substance easily. Why? Because the metallic substance has the free electron. We know that the atoms that are present in each and every materials, but for the metallic atoms, the atoms has the free electron, and when the potential difference is supplied across the two ends of the metal, then the free electron starts to flow. Free electron starts to flow. And due to this flow of free electron, the current is passing through the metal. But for the insulator, there is no free electron, so this cannot pass, cannot flow. So no electron can flow through this insulator, and there is no current flow. That means we can say the current flow through the metal is due to the flow of free electron present in the metal. Next we go for that Ohm's law. Most important things in this chapter. We know that the water is flowing, just to people discuss about that. Water was flowing from high water level to low water level. And the flow of water will be more if the water level difference is more. So as the water level difference is more, the water will flow more fastly. Similarly, if current is flowing through any conductor, current flow means flow of charge. Why the charge will flow? Due to the potential difference. The charge particles are flowing due to the potential difference. So if the charge particles are flowing due to the potential difference, if the potential difference is more, then the more charge particle will flow and current flow will more. So you can say that if the potential difference, suppose PD stands for potential difference. Suppose potential difference between two ends is V. Two ends of a conductor. Potential difference, the two ends of a conductor is V, and the current flow through this conductor is I. Current flow is equal to I. Current flow means flow of charge particle. Why the charge particles are flowing? Due to the potential difference. If the potential difference is more charge particle will flow, current flow will be more. That means we can say that if the potential difference is increased between the two ends of the conductor, then more current will flow. And if the potential difference between the two ends of the conductor is decreased, then the current flow will be decreased. So what is the relation between the I and V? That means we can say here I depends on V, current flow depends on the potential difference. So here we can say that according to the Ohm's law, I proportional to V. Current flow is directly proportional to the potential difference across the two ends of the conductor. Remember one thing, now the temperature and other physical things remain constant. remain fixed. So current flow depends on the potential difference. How? Directly proportional. Directly proportional. Now if you replace this proportional sign by the equal sign, if you want to replace this proportional sign by the equal sign, then we take a constant here I is equal to, we replace this proportional sign by the equal sign, then we take a constant k and this is v. K is the constant. So from here we can write I is equal to 1 by r into v. Now one question, what is 1 by r? Remember these things. K is equal to 1 by r. I will discuss about k and r. So from this equation you can write v is equal to I r. This is the mathematical expression of Ohm's law. V is equal to I r. So from the beginning, if I say the Ohm's law states that current flow through any conductor is directly proportional to the potential difference across the two ends of the conductor when the temperature and other physical quantities are remain constant. Now question, this K, this R, what is this K and what is this R? Now we'll discuss about it. This K, name of this constant is known as the conductance and R is resistance. What is this things? Conductance and resistance, these are the property of a conductor. Which property? Conductance is the property for which the current is allowed to pass through the conductor. For this conductance property, current is allowed to pass through the conductor. And resistance, this is the property also of a conductor. For this property, current is opposed to flow through the conductor. Current is opposed to flow. So for the K, conductance, current is allowed to flow. Resistance, current is opposed to flow, opposite. That's why the relation between K and R is K is equal to 1 by R. If K is increased, R will be decreased. If R is increased, K will be decreased, opposite. So one example, suppose copper. Copper is a good conductor. So for the copper, if you say about the conductance and resistance, which one is more? Resistance is more. Sorry, resistance is less and conductance is more. That's why conductance more means current is allowed to pass through it, and resistance is less means current is not opposed strongly when it is passing through it. So we can say that for a good conductor, conductance is high, resistance is low. But for the insulator or bad conductor like wood or plastic, here the resistance is high, strongly opposed to flow the current. Resistance is high, but conductance is low. So conductor where K is high, R is low. Insulator where R is high, K is low. So today, after this, today we discuss about the from the potential difference, how for the potential difference current is flowing. Then how the current flow depends on the potential difference. Then from that portion we discuss about the Ohm's law. From the Ohm's law we discuss about the conductance and resistance. Today these topics are discussed and I will send the assignment on these topics. So wait for the assignment. Thank you.